June 18, 1944. A Wehrmacht ordnance testing facility outside Berlin. Hauptmann Klaus Richter placed the captured American rifle on the test bench, its dark walnut stock still marked with mud from Norman dye beaches. The M1 Garand. Intelligence reports claimed American infantry squads were somehow firing faster than machine gun crews. Impossible, Richter thought. His men carried Karabiner 98K rifles, proven Mauser bolt actions that had served Germany since before the Great War. Every German soldier knew the routine. Aim, fire, work the bolt, eject the spent cartridge, chamber a new round, aim again. 15 aimed shots per minute for a well-trained rifleman. Richter loaded the Garand's 8-round on-block clip and shouldered the weapon. He pulled the trigger. The rifle fired, the bolt cycled automatically, and a fresh round sat chambered without him touching anything. He pulled the trigger again and again. 8 shots in 12 seconds, faster than he could work a Car 98K's bolt twice. The metallic ping as the empty clip ejected echoed through the testing bay. His assistant, Lieutenant Weber, stood frozen. "They all have this?" "Every American rifleman," Richter said quietly, setting the weapon down. "Standard issue." What German weapons experts were discovering, and what Wehrmacht commanders had learned through bitter experience in North Africa and Normandy, was that America had brought a rifle to war that fired faster than Germany's best infantry squads could answer, creating a firepower advantage so profound that it would reshape how both sides thought about infantry combat for the rest of the war and influence small arms design for generations after. The engagement began at dawn on November 10, 1942, in the hills outside Oran, Algeria. Elements of Oberst Hermann Baum's German mission, Wehrmacht advisors assisting Vichy French forces, watched American infantry from the 1st Infantry Division advance through olive groves below their position. Baum had fought on the Eastern Front and knew the rhythm of infantry combat. Riflemen fired, worked their bolts, fired again. Machine gunners laid down suppressive bursts. The pattern was familiar, predictable, manageable, but the sound reaching his position wasn't right. American rifle fire came in sustained, rapid volleys. Not the measured cadence of bolt-action rifles, but something approaching machine gun fire. Baum raised his binoculars. The Americans were using rifles, not automatic weapons. Yet the volume of fire seemed impossible. He counted 12 soldiers in one squad laying down fire that sounded like 40. Feldwebel Ernst Müller, commanding a small German advisory section, reported the same phenomenon from his position, watching American troops clear a French fortification. "They're all shooting automatically," he said, confusion evident in his voice. "Every single rifleman." Baum knew that was impossible. No army equipped every infantryman with automatic weapons. The cost, the complexity, the ammunition consumption, it couldn't be done. But the evidence of his ears contradicted what logic told him must be true. The German and French positions fell within 2 hours. American rifle fire had been relentless, giving defenders no opportunity to maneuver or counterattack. When German officers examined abandoned American positions, they found spent cartridges in quantities that confirmed what they'd heard. Individual riflemen had fired dozens of rounds rapidly without the pauses required for working a bolt-action rifle. Wehrmacht intelligence officers in Tunisia began collecting reports from German units, engaging American forces throughout Operation Torch. The pattern repeated consistently across the North African theater. German soldiers described American infantry squads firing with what seemed like impossible rapidity. Some reports claimed Americans all have machine guns. Others described rifle fire that never stops, they just keep shooting. Captured American rifles reached German ordnance testing facilities by December 1942, the M1 Garand. Wehrmacht engineers examining the weapon understood immediately what they were facing. It was semi-automatic, gas-operated, automatically cycling after each shot. No manual bolt operation required. An experienced rifleman could fire the 8-round clip in under 10 seconds with aimed shots. German after-action reports from Tunisia documented the tactical implications. American rifle squads delivered approximately 3 times the sustained fire of equivalent German squads armed with Karabiner 98K bolt-action rifles. In firefights, that disparity meant American infantry could suppress, maneuver, and assault more effectively. German units that would have held positions against bolt-action rifles retreated under the sustained fire from M1-equipped squads. Oberstbaum filed his assessment to Wehrmacht headquarters in February 1943 after American forces pushed through the Kasserine Pass. The American semi-automatic rifle represents significant tactical advantage. Recommend immediate priority for captured weapons analysis and consideration of German semi-automatic rifle program. His report joined dozens of similar assessments from officers across the North African and Italian theaters. But understanding the weapon was different from countering it. Germany had attempted semi-automatic rifle programs. The Gewehr 41 showed promise but suffered reliability problems. Even if German engineers could design an equivalent weapon, producing it in sufficient quantities to equip Wehrmacht infantry would require industrial capacity that Germany, already struggling with war production on multiple fronts, simply didn't possess. American infantrymen landing in Sicily in July 1943 and at Salerno in September carried M1 Garands in increasing numbers. By mid-1944, virtually every American rifleman in Italy had one. German defenders faced the firepower advantage in every engagement, knowing their Kar 98K bolt actions required 3 to 4 seconds between shots, while Americans could fire as fast as they could pull the trigger. The technological gap wasn't closing. If anything, it was widening as American production scaled and German capacity declined. The firepower disparity that German soldiers first encountered in North African olive groves would define infantry combat for the rest of the war. A persistent, measurable advantage that influenced every ground engagement and forced German tactical doctrine to adapt to facing an enemy whose standard riflemen could fire 3 times faster than Germany's best-trained infantry. The challenge John Cancius Garand faced in the 1920s wasn't novel. Every major military power wanted a semi-automatic rifle. The problem was making one reliable enough for combat use by average soldiers under conditions that destroyed finicky weapons. Previous attempts had produced rifles requiring constant maintenance, cleaning, and adjustment. They jammed in mud, they failed in extreme temperatures, they were too complex for field repair. Garand, a Canadian-born engineer working at Springfield Armory, approached the problem through elegant simplicity. His gas-operated system used the rifle's own firing process to cycle the action automatically. When a cartridge fired, expanding gases propelled the bullet down the barrel. Near the muzzle, a small gas port, a hole drilled at 90 degrees through the barrel, diverted a portion of those gases into a gas cylinder surrounding the barrel. Inside the gas cylinder, high-pressure gas struck a long-stroke piston attached to the operating rod. The force drove the operating rod rearward. As the operating rod moved, a camming surface inside its recess engaged the operating lug of the bolt, forcing the lug upward and disengaging the bolt's locking lugs from their recesses in the receiver. The bolt unlocked and began traveling rearward with the operating rod. The rearward motion ejected the spent cartridge case through the ejection port on the right side of the receiver. Simultaneously, the operating rod compressed the operating rod spring. When the operating rod reached full rearward travel, the compressed spring drove it forward again, stripping a fresh cartridge from the 8-round on-block clip and chambering it. The camming action reversed. The operating lug was forced downward, engaging the locking lugs, and the bolt locked securely into battery. The rifle was ready to fire again. The entire cycle took a fraction of a second. A soldier simply pulled the trigger and the rifle handled everything else. Ejection, feeding, chambering, locking. No manual bolt operation. No pause between shots except the time it took to reacquire the target and pull the trigger again. Garand's system proved remarkably robust. The gas port design he adopted in 1939 simplified his original gas trap concept that had proven too complex. The revised system used fewer parts, operated more reliably, and tolerated dirt, sand, mud, rain, and temperature extremes that disabled more complicated designs. The 30-06 Springfield cartridge provided stopping power equivalent to bolt-action rifles, while the semi-automatic action multiplied rate of fire approximately threefold. The 8-round on-block clip fed smoothly through each firing cycle. When the last round was fired, the empty clip ejected automatically with a distinctive metallic ping that became the rifle's signature sound. Soldiers could then insert a fresh clip and continue firing without manually operating any controls beyond the trigger. The design's elegance lay in its simplicity relative to function. Competitors had tried gas-operated systems that required multiple gas settings for different conditions, or recoil-operated systems with complex spring arrangements, or delayed blowback systems with temperamental timing. Garand's system worked with one gas setting, relatively few moving parts, and forgiving tolerances that maintained function even when components wore or got dirty. Field maintenance was straightforward enough for average soldiers. The rifle disassembled into three main groups: trigger group, barrel and receiver group, and stock group. Basic cleaning required no special tools. The operating rod's piston end was intentionally bent to prevent binding against the barrel, a detail that confused soldiers initially, but that represented careful engineering to ensure reliability. The rifle weighed 9.5 pounds empty, acceptable for infantry use. Its overall length of 43.5 inches was comparable to bolt-action rifles. The semi-automatic mechanism added complexity but not excessive weight or bulk. And most critically, the design proved manufacturable at industrial scale, using existing metalworking techniques and machinery. But engineering elegance meant nothing if American industry couldn't produce the rifles in quantities sufficient to equip entire armies. Garand had designed a weapon that solved the semi-automatic reliability problem. The next challenge was proving that millions of complex gas-operated rifles could be manufactured to consistent standards while maintaining quality control, a manufacturing feat that would test American industrial capacity as thoroughly as the rifle's design-tested engineering ingenuity. The M1 Garand represented more than mechanical innovation. It embodied a philosophy about infantry weapons, that reliability mattered more than perfection, that simplicity enabled mass production, and that giving average soldiers superior tools multiplied their effectiveness more than training elite specialists with finicky equipment. Whether American factories could validate that philosophy by producing millions of functioning rifles would determine if Garand's elegant design remained a prototype curiosity or became the weapon that redefined infantry combat. Springfield Armory began mass production of the M1 Garand in September 1937 at a rate of 10 rifles per day. By January 1941, output had reached 600 per day. The numbers told the story of American industrial mobilization, not through dramatic leaps, but through methodical, relentless scaling of production capacity. The challenge in 1940 was enormous. The U.S. Army planned to expand from 190,000 men to over 1.4 million through conscription. Every new infantryman needed a rifle. The M1 Garand was complex compared to bolt-action rifles, more parts, tighter tolerances, gas systems requiring precision machining. Skeptics questioned whether American industry could manufacture millions of semi-automatic rifles to consistent standards while maintaining quality. Springfield Armory proved it could. Engineers developed manufacturing techniques using interchangeable parts and assembly line methods. Each rifle required approximately 48 machining operations on the receiver alone. Barrel production demanded precision boring and rifling. The gas cylinder, operating rod, trigger mechanism. Each component needed machining within thousandths of an inch tolerance to ensure reliable function. Winchester Repeating Arms received an educational production contract in 1940 for 65,000 rifles. The contract's purpose wasn't just producing rifles, but developing Winchester's capacity to manufacture Garands at scale if war came. When Japan attacked Pearl Harbor in December 1941, Winchester ramped up production quickly because they had already solved the manufacturing challenges. By 1943, combined production from Springfield and Winchester exceeded 400,000 rifles annually. In January 1944 alone, Springfield produced 122,000 M1 Garands, more than 4,000 per day. The production achievement was staggering. During World War II, Springfield manufactured approximately 3.5 million M1 Garands. Winchester produced another 580. Combined World War II production totaled over 4 million rifles. The numbers represented more than manufacturing capacity. They demonstrated that American industry could produce complex weapons at scales previously thought impossible. Germany recognized the M1's tactical advantage by 1942, but lacked industrial capacity to equip their infantry with equivalent semi-automatic rifles. The Gewehr 43 program eventually produced roughly 400,000 rifles total, about one-tenth of American M1 production, and most German infantry continued using Kar 98K bolt actions throughout the war. The firepower disparity was mathematical. A rifleman with a Kar 98K could fire approximately 15 aimed shots per minute. The time required to work the bolt between each shot limited sustained fire. A rifleman with an M1 Garand could fire 40 to 50 aimed shots per minute, limited only by how quickly he could acquire targets and pull the trigger. The 3-to-1 firepower advantage meant American infantry squads could suppress, maneuver, and assault more effectively than German equivalents. In combat, the disparity manifested in every firefight. German soldiers reported feeling overwhelmed by American rifle fire's volume and intensity. American after-action reports noted that M1-equipped squads could suppress enemy positions with rifle fire alone, often without machine gun support. The weapon gave every American rifleman firepower, approaching what bolt-action armies reserved for specialized troops with automatic weapons. The production achievement extended beyond quantity to quality control. Rifles manufactured in 1943 functioned as reliably as those made in 1937. Parts from different production runs were interchangeable. Field armorers could swap components between rifles without fitting or adjustment. The manufacturing precision that made this possible represented American industrial sophistication as much as the rifles themselves. By 1945, virtually every American infantryman carried an M1 Garand. The rifle had become standard issue, not a specialized weapon for elite units, but the default armament for average soldiers. Germany never achieved equivalent distribution of semi-automatic rifles. The industrial capacity gap translated directly into tactical advantage in every ground engagement. But manufacturing millions of superior weapons was only half the equation. American infantry doctrine had to adapt to exploit the M1's capabilities. Tactics developed for bolt-action rifles didn't fully leverage semi-automatic fire's advantages. Squad leaders needed to understand how rapid-fire rifles changed fire and maneuver dynamics. Training programs had to teach soldiers when to fire rapidly and when to fire deliberately. The rifle's production represented American industrial might. Its tactical employment would determine whether that industrial advantage translated into battlefield victories. Superior weapons in the hands of poorly trained troops wasted the advantage. The M1 Garand gave American infantry potential firepower superiority. Realizing that potential required doctrine, training, and tactical innovation that matched the weapon's capabilities. Production continued through 1945, with Springfield's last wartime rifles bearing serial numbers in the 3,000 and 88,000 range. The rifles that rolled off production lines in Springfield, Massachusetts, and New Haven, Connecticut represented more than metal and wood. They embodied American confidence that industrial capacity could be translated into military superiority, that giving every soldier superior tools multiplied effectiveness more than any other investment, and that wars were won not just on battlefields, but in factories where superior weapons were mass-produced at scales enemies couldn't match. Hauptmann Klaus Richter submitted his report to Wehrmacht Waffenamt headquarters in Berlin in July 1942. The captured American M1 Garand represented significant tactical advantage. His recommendation was direct. German infantry needed equivalent firepower. The report joined dozens of similar assessments from officers across North African and Eastern Front theaters. German ordnance officials didn't need convincing. They had already recognized the problem. Germany's semi-automatic rifle programs, the Gewehr 41 and Walther and Mauser variants, had been in development since 1941, triggered partly by encounters with Soviet SVT-40 rifles and partly by intelligence reports about American M1 production. But recognizing a problem and solving it were different challenges entirely. The Gewehr 41 program produced two designs, G41M from Mauser and G41W from Walther. Both attempted to meet German Army specifications that, in retrospect, made the task nearly impossible. The specifications demanded no gas port drilled through the barrel, based on fears that ports would cause premature bore erosion. Instead, both designs used gas trap systems at the muzzle, complex mechanisms that captured expanding gases after the bullet left the barrel and redirected them to operate the action. The G41M proved disastrously unreliable. Mauser produced at least 12,755 rifles before the program was abandoned. The G41W fared better but still suffered chronic reliability problems. The gas trap systems fouled quickly, required constant maintenance, and failed under field conditions that the simpler M1 Garand handled routinely. By 1942, German troops testing G41s in combat reported the weapons were inferior to captured Soviet SVT-40s and dramatically inferior to captured American M1 Garands. The solution came from studying captured enemy weapons. Soviet SVT-40 rifles used simple gas ports drilled through the barrel, exactly what German specifications had prohibited. The system worked reliably despite theoretical concerns about bore erosion. In 1943, Walter redesigned the G41W, incorporating a gas-operated system directly copied from the SVT-40, combined with other improvements including a detachable 10-round magazine. The result was the Gewehr 43. The G43 worked. It was reliable, reasonably accurate, and gave German infantry semi-automatic firepower approaching American M1 capabilities. Units that received G43s reported significantly improved combat effectiveness. The rifle validated the concept. German soldiers could use semi-automatic rifles as effectively as Americans if given equivalent weapons. But production numbers told a grimmer story. Between October 1943 and May 1945, Germany produced approximately 413 Gewehr 43 and Karabiner 43 rifles combined. The name changed from Gewehr to Karabiner in April 1944, but the weapons were identical. Total production barely exceeded 400,000, roughly one-tenth of American M1 Garand production during the same period. The disparity revealed Germany's fundamental problem. Wehrmacht planners intended to equip each infantry company with 19 G43s, including 10 fitted with telescopic sights for designated marksman roles. That goal was never achieved. Most German infantry continued using Karabiner 98K bolt-action rifles throughout the war. The few G43s produced went to priority units, elite divisions, units facing heaviest, combat, or specific roles like snipers and designated marksmen. German industrial capacity simply couldn't match American production, while simultaneously manufacturing tanks, aircraft, artillery, ammunition, and everything else modern warfare required. Germany faced Allied bombing campaigns that disrupted production facilities. Labor shortages forced use of slave workers from Buchenwald and Neuengamme concentration camps to supplement depleted factory staffs. Raw materials grew scarce as Allied advances cut off access to resources. Late-war G43s showed increasingly crude finish and rougher machining as quality standards dropped to maintain production rates. By 1944, Germany faced invasion from both east and west. The firepower gap between American-equipped and German infantry widened rather than narrowed. American factories were producing M1 Garands at over 400,000 annually, enough to equip every new infantry division with semi-automatic rifles as standard issue. Germany struggled to produce 200,000 G43s annually while maintaining production of everything else the Wehrmacht needed. The G43 program represented Germany's response to American firepower advantage. Technically successful, tactically sound, but strategically insufficient. Recognizing the problem didn't help when industrial capacity couldn't implement the solution at necessary scale. Every German soldier who received a G43 gained firepower approaching American infantry. But for every German with a G43, 3 still carried Kar 98K bolt actions, while their American opponents all had Garands. Wehrmacht tactical doctrine adapted to acknowledge the disparity. German infantry were taught to rely more heavily on machine guns for suppressive fire, to use superior defensive positions to offset firepower disadvantages, and to avoid prolonged firefights where American semi-automatic rifles' sustained fire proved decisive. The adaptations helped German forces remain effective despite technological disadvantage, but couldn't eliminate it. By spring 1945, as Germany collapsed, the G43 program ended with production facilities captured or destroyed. The rifles that had been produced served effectively but never in numbers sufficient to change strategic balance. The few 100,000 G43s couldn't offset the millions of M1 Garands equipping American forces converging on Germany from east and west. Industrial capacity had determined tactical capabilities, and Germany simply lacked resources to match American production while fighting a multi-front total war that consumed every available resource. The landing craft ramp dropped at 0630 hours on June 6, 1944. Private First Class Harold Baumgarten of Company B, 116th Infantry Regiment, stepped into chest-deep water off Omaha Beach, carrying his M1 Garand above his head to keep it dry. Around him, German machine gun fire churned the water into foam. Men fell before reaching the beach. Those who made it to the sand found themselves trapped on a killing ground. Omaha Beach was, as one historian later calculated, filled with an estimated 32 rounds per square foot every 10 seconds. German MG-42 machine guns in concrete pillboxes and fortified positions commanded the entire beach. The sound of their fire, described by soldiers as Hitler's buzzsaw or tearing linoleum, dominated the chaos. German defenders in Widerstands Nest 61 and other strongpoints had clear fields of fire across open sand where American infantry had almost no cover. But American troops hitting the beach weren't armed with bolt-action rifles. They carried M1 Garands. As soldiers reached the seawall and shingle, they began returning fire. The semi-automatic rifles allowed them to fire rapidly while moving, laying down sustained volleys that, combined with Browning automatic rifles and machine guns, created enough suppression for follow-on waves to advance. Sergeant Philip Stroyny of the 16th Infantry Regiment used his Garand to engage German defenders at Widerstands Nest 61 after his bazooka ran out of ammunition. He fired at a fleeing German soldier from an exposed position. An enemy rifleman spotted him and fired. The bullet struck Stroyny's helmet above his left eye, deflected around his skull, and exited near his left ear. A superficial wound that would have been fatal with direct penetration. Stroyny kept fighting. The M1's advantage wasn't just rate of fire, it was sustained fire while maintaining pressure. Bolt-action rifles required soldiers to take their eyes off targets between shots to work the bolt, ejecting spent cartridges and chambering new rounds. The M1 cycled automatically. Soldiers could keep their sights on targets, firing as rapidly as they could acquire and engage. In the chaos of Omaha Beach, those seconds mattered. German after-action reports from Normandy noted the unprecedented volume of American rifle fire. Defenders estimated they faced twice their actual numbers because rifle fire sounded like automatic weapons. Wehrmacht soldiers reported, "Americans all have machine guns," the same assessment German troops had made in North Africa 2 years earlier. The volume of semi-automatic rifle fire exceeded what bolt-action armies thought possible from standard infantry. The fight to secure Omaha Beach lasted hours. By afternoon, American forces had pushed off the beach and begun securing the draws, the natural valleys offering exits from the killing ground. The M1 Garand hadn't made the assault easy or bloodless, but it had given individual soldiers firepower that bolt-action rifles couldn't match. The hedgerow fighting through July and August demonstrated the Garand's advantages in different terrain. Normandy's bocage country, fields separated by ancient earthen walls topped with dense vegetation, created maze-like battlefield where engagements happened at ranges of 50 yards or less. Soldiers often had seconds to spot enemies, acquire targets, and fire. In sudden close-range firefights, the M1's rapid fire proved essential. A soldier encountering a German position could fire multiple aimed shots before enemies could work bolt actions twice. The advantage wasn't overwhelming. German MG-42 machine guns still provided devastating firepower, and German infantry used superior defensive positions to offset American firepower advantages. But in sustained firefights, American rifle squads could maintain pressure that forced German defenders to retreat or be suppressed. One drawback became legend among American troops: the distinctive metallic ping when the 8-round en-bloc clip ejected after firing the last shot. German soldiers learned to recognize the sound and time counterattacks. American infantry adapted by carrying spare clips to throw after firing only a few rounds, creating the distinctive ping while their rifles remained loaded, then waiting for German heads to pop up. The tactic demonstrated the ingenuity American soldiers developed to exploit their weapons' advantages while mitigating vulnerabilities. But superior weapons didn't guarantee victory. The Normandy campaign cost American forces approximately 73,000 casualties between D-Day and the breakout at St. Lo in late July. The M1 Garand gave individual soldiers firepower advantage, but German defensive positions, artillery, machine guns, and tactical skill remained deadly. Weapons alone didn't determine outcomes. They provided advantages that courage, training, and tactical competence had to exploit. By August 1944, as American forces broke out of Normandy and raced across France, the M1 Garand had proven itself in the war's largest amphibious assault and in brutal hedgerow fighting. German reports consistently noted American infantry firepower superiority, but the rifle's greatest test still lay ahead. Winter fighting in forests and cities where close-range combat would push both weapons and soldiers to their limits. On January 26, 1945, Lieutenant General George S. Patton sat at his desk at 3rd Army Headquarters and wrote a letter to Major General Levin H. Campbell, the War Department's Chief of Ordnance. The letter's opening line would become one of the most famous quotes in American military history. "In my opinion, the M1 rifle is the greatest battle implement ever devised." Patton didn't utter those words dramatically on a battlefield or shout them to assembled troops. He wrote them in official correspondence, calm, measured, deliberate. The context mattered. Patton had commanded 3rd Army through the breakout from Normandy, the race across France, the relief of Bastogne during the Battle of the Bulge, and the drive into Germany. He had observed his infantry's combat effectiveness firsthand across every terrain and tactical situation modern warfare offered. His assessment wasn't hyperbole. Patton understood infantry weapons from decades of military experience. He had seen bolt-action rifles, automatic weapons, artillery, tanks. He knew what made weapons effective in combat. The M1 Garand's combination of firepower, reliability, and ease of use gave American infantry tactical superiority that Patton recognized as decisive. The letter continued beyond the famous opening line. Patton praised American ordnance broadly. "My admiration for ordnance products does not stop with the M1 rifle. Our machine guns, mortars, artillery, and tanks are without equal." But he singled out the M1 for special recognition because it armed every rifleman, not specialist troops or elite units, but average American infantrymen who formed the bulk of combat forces. Patton understood that high-quality weaponry was useless without well-trained soldiers. In his letter, he referred to American troops as unconquerable veterans, whose skill with ordnance tools ensured the utter destruction of the armed forces of our enemies. The rifle was tool. The soldiers wielding it made the difference. But superior tools and skilled hands multiplied effectiveness beyond what inferior weapons could achieve regardless of training. The praise was particularly meaningful coming from Patton, a general whose reputation for harsh criticism and exacting standards was legendary. Soldiers feared his inspections. Officers dreaded his assessments. When Patton commended something, the praise carried weight because it was earned rather than given freely. Post-war analysis confirmed Patton's judgment. Military forces worldwide studied American infantry tactics and equipment during the late 1940s and 1950s. The conclusion was near universal. Semi-automatic rifles represented the future of infantry arms. Nations that had fought with bolt actions during Oued Tunis, Britain, France, Soviet Union, even Germany after its division, adopted semi-automatic designs for post-war service rifles. Many of those designs were directly influenced by the M1 Garand's gas-operated system. The Egyptian Hakim, the Swedish AG-42, the Belgian FN-49, all used gas-operated semi-automatic mechanisms derived from Garand's engineering. The Soviet SKS, while based partly on the earlier SVT-40, incorporated design elements that acknowledged American semi-automatic rifle success. Even the FN-FAL and G3 battle rifles that dominated NATO and Warsaw Pact inventories through the Cold War descended from the principle Garand had proven. Infantry needed rapid-fire rifles as standard equipment. The M1's service life extended well beyond WWIB. American forces carried Garands through Korea, where the rifle proved equally effective in different terrain and climate. The weapon that had performed reliably in North African heat, Italian mountains, French hedgerows, and German forests worked just as well in Korean cold. Production resumed during Korea with International Harvester manufacturing 337,623 additional M1s between 1952 and 1956. The M14 rifle that replaced the M1 in 1958 was essentially an evolved Garand, gas-operated semi-automatic mechanism, similar operating system but chambered for the 7.62 51mm NATO cartridge and equipped with a detachable 20-round magazine. The M14 maintained the Garand's basic design philosophy while addressing its limitations. Later rifles like the M16 used different operating systems, but they validated the fundamental principle Garand had established. Infantry rifles should fire as rapidly as soldiers could pull triggers. The rifle's cultural legacy matched its tactical influence. The M1 Garand became symbol of American military excellence, reliable, powerful, technologically superior. Veterans returning from WIWA and Korea spoke of their Garands with affection and respect that few weapons inspire. The distinctive ping of the ejecting on-block clip became as recognizable as the rifle's silhouette. Museum collections and private collectors preserved M1s as artifacts of American military heritage. But the Garand also represented a specific historical moment, when American industrial capacity and design philosophy combined to create battlefield advantage that enemies recognized but couldn't match. Germany had designed competitive semi-automatic rifles but lacked industrial capacity to produce them at necessary scale. Japan never fielded semi-automatic rifles in significant numbers. Soviet semi-automatics like the SVT-40 were produced in substantial quantities, but plagued by reliability problems that the M1 avoided. Patton's letter to General Campbell preserved what might have been lost as routine correspondence. The quote it contained became legendary because it captured truth about the rifle's significance. The M1 Garand was, in Patton's assessment and in subsequent historical judgment, among the most important infantry weapons ever fielded, not because it was perfect, but because it gave average soldiers firepower advantage that influenced every ground engagement and established semi-automatic fire as baseline infantry capability that modern militaries now consider fundamental rather than revolutionary. 80 years after World War II ended, military historians examining infantry weapons evolution recognized the M1 Garand as pivotal innovation that permanently changed how armies equipped their soldiers. Modern infantrymen carrying select fire rifles take semi-automatic capability for granted. It's baseline expectation rather than revolutionary technology. But in the 1940s, giving every rifleman rapid-fire capability represented transformation as profound as repeating rifles replacing muzzleloaders in the 19th century. The numbers documented the advantage. U.S. Army tests published in the Cavalry Journal in 1937 compared M19903 Springfield bolt-action rifles against M1 Garands at 350 to 600 yards. Under limited rate of fire conditions, 24 rounds per minute for M1s versus 10 for M1903s, 6 riflemen with Garands fired 124 rounds and scored 14 hits. 6 riflemen with M11903s fired 60 rounds and scored 6 hits. The M1 was statistically twice as effective as bolt-action rifles, the advantage multiplied at squad level. An 8-man squad test published in Army Ordnance in 1940 measured effectiveness against moving targets at 300 yards. The M1 equipped squad engaged and hit all targets significantly faster than the bolt-action squad. The semi-automatic rifles allowed soldiers to maintain sight pictures between shots, acquire targets faster, and fire sustained volleys that bolt actions couldn't match. But the M1's greatest contribution wasn't just rate of fire, it was democratizing that firepower. Previous armies concentrated automatic weapons in specialized roles. Machine gunners, submachine gunners, automatic riflemen, these specialists provided rapid fire while standard riflemen supported with slower bolt actions. The M1 Garand gave every rifleman firepower approaching what earlier armies reserved for specialists. The tactical implications were profound. American infantry squads could lay down suppressive fire with rifles alone, maintaining pressure during final assault phases when covering fire had to lift. Soldiers could advance while firing from the shoulder or hip, marching fire that bolt actions made impractical. The rifle enabled tactics that earlier infantry couldn't execute. Post-war militaries worldwide absorbed the lesson. Britain, which had maintained bolt-action Lee-Enfield rifles through Batmux, despite their excellent rate of fire, 15-20 aimed shots per minute, adopted the semi-automatic FNFL in the 1950s. The Soviet Union, which had produced nearly 2 million SVT-40 semi-automatic rifles during WWSU, but withdrew many from frontline service due to reliability problems, developed the SKS and later the AK-47, incorporating lessons from semi-automatic rifle programs. France, Germany, Japan, nations that had fought primarily with bolt actions, they adopted semi-automatic or automatic rifles for post-war service. Many designs incorporated principles Garand had validated. Gas-operated systems became standard. The concept that infantry rifles should fire as rapidly as soldiers could pull triggers replaced earlier doctrine emphasizing deliberate, slow-aimed fire. The M14 that succeeded the M1 in U.S. service was essentially an evolved Garand. Similar operating system, same gas-operated mechanism, but chambered for 7.62 NATO and equipped with a 20-round detachable magazine. The rifle's service life validated its design. Marines carried M1 Garands from Guadalcanal to Iwo Jima, through Korea's bitter cold at Chosin Reservoir, where soldiers stripped lubricants and ran the rifles dry rather than risk oil freezing, and the weapons kept functioning. The same rifle that performed in North African heat worked in Korean winter, a testament to engineering robustness that few weapons achieve. But the M1's legacy also revealed broader truths about military power. Technological advantage mattered enormously. German soldiers who tested captured Garands immediately recognized American firepower superiority, but recognizing advantage didn't help, without industrial capacity to respond. Germany designed competitive semi-automatic rifles but produced only 400,000 G43s compared to over 4 million American M1s. The disparity revealed how industrial capacity determined tactical capabilities. The lesson extended beyond World War II. American approach to warfare emphasized equipping individual soldiers with technological advantages, superior weapons, superior equipment, superior logistics support. The philosophy assumed that giving average soldiers superior tools multiplied effectiveness more than training elite specialists with inferior equipment. The M1 validated that approach. Every American infantryman armed with a Garand represented firepower superiority over 3 German riflemen with Kar 98Ks. The weapon's cultural legacy matched its tactical significance. The M1 Garand became symbol of American military excellence, reliable, powerful, technologically superior. Veterans spoke of their Garands with affection unusual for military equipment. The distinctive ping of the ejecting clip became as recognizable as the rifle's silhouette. Post-war surplus programs distributed hundreds of thousands of M1s to civilian marksmanship clubs, making the weapon familiar to generations who never served in combat. Modern infantry rifles descended from principles the M1 established. The M16, M4, and successors used different operating systems and fire intermediate power cartridges rather than full-power rifle rounds. But they validate Garand's fundamental insight. Infantry weapons should maximize sustained firepower rather than optimizing for accuracy at extreme ranges that combat rarely required. The M1 Garand succeeded because it combined excellent engineering with industrial capacity to produce millions while maintaining quality. John Garand designed a weapon that was simple enough for mass production, reliable enough for combat conditions, and effective enough to give American infantry measurable advantage in every engagement. But the rifle's success also depended on American factories that could manufacture complex weapons at unprecedented scales. A combination of design excellence and industrial might that enemies recognized but couldn't match. The legacy endures. Sometimes the most important innovations aren't the most dramatic but the most practical. Weapons that work reliably, that average soldiers can maintain and employ effectively, that can be produced in millions rather than thousands. The M1 Garand was all of those things, and in being so, it changed infantry combat permanently, establishing that modern soldiers required rapid-fire weapons as baseline capability, and proving that technological advantages, backed by industrial capacity to implement them at scale, could determine strategic outcomes as surely as battlefield tactics or operational brilliance.